welcome to Class 2, Unit A. As a way of talking about what we're going to start with today, I hunted through my Star Trek memorabilia and found these, my official dilithium crystals. And I thought about using these because suppose we had a very important problem. Suppose we needed to divide these crystals up among our allies, the Vulcans, the Klingons, and the Romulans. Well, here's how we would do it. We have to investigate some sort of mathematical process for doing this, for splitting them out so that everybody gets their fair share of dilithium crystals, which of course are very important. Now, it's easy to push things around on a table, but let's see how we do this mathematically. Let's get started. Okay, so here are some of the things that you're going to be able to do when you've finished all the work associated with this unit. You're going to be able to divide whole numbers. You're going to be able to solve word problems involving division, and you're going to be able to solve equations involving division. So, division asks the question, how can I split things between groups so that each group has an equal amount? So for example, here, if I split them into 3 groups, there would be 6 in each group. So here's a very easy problem. If there are 12 students in my class, how many study groups of 4 can I have? And if I do that, I split it out. And of course, you know the way we usually do this, we can count by 3s. And all the 1s go over here, all the 2s go over here, all the 3s go over here. So in a way, that's dividing my people into the 3 groups. All right, everyone count by 3s. You've all probably done that a lot. So we're going to investigate how you do that mathematically. And we're going to use a process called division. So let's look at some of the vocabulary associated with that process. The number you're dividing, the number of things you have that you want to divide into pieces, is called the dividend. Then the symbol, that line with a dot above and below it, which actually, if you think about it, looks like things divided, is one way that you can represent division. Then the number you're dividing by, the number of groups you want to separate something into, is called the divisor, and the result is called the quotient. Let's look at some of the ways that we can represent division. That symbol with the 2 dots, one over the other, isn't the only way, and we'll be mixing them up just like we mix up the way we do it with multiplication. Anyway, here are the ways we can do it. Well, this way you've already seen. 12 divided by 3 is equal to 4. Another way we can represent division is what might be fractional notation, where we have 12, then the dividing line over the 3. So 12 over 3, or 12 divided by 3, is 4. And this way might also be familiar to you from school, where you have 12 with the division symbol divided by 3 equals 4. This particular last symbol is mostly useful when we're doing long division. In other words, we're trying to divide something complicated without a dreaded calculator. So let's look at the process. So division is related to multiplication. So 8 divided by 4 is equal to 2. If I have 8 things and split it up into 4 groups, there are 2 things in each group. But here's the relationship to multiplication. 4 things in 2 groups is equal to 8. So again, just like subtraction is the inverse of addition, division is the inverse operation to multiplication. And we might remember that multiplication was a math shortcut for repeated addition. So, in that same sense, we can say that division is a process of successive subtraction. Watch how this works. So I have 8 minus 4 one time, so there's 4 left. Then I have 8 minus 4 2 times, and I've taken away 4 twice. Notice where the 2 is there, so there's nothing left. So you can think of division being a process of successive taking away until, hopefully, there's nothing left. So multiplication is successive addition. Division you can think of successive subtraction, a process of taking away, taking away, taking away, and counting how many times you take things away until there's nothing left. And we can illustrate it here. So step 1, I take 4 away. I put them, okay, you're over in this group. Step 2, I take another 4 away, and then there's nothing left, and I've done it in 2 steps. Now, sometimes if, for example, I have 10 hot dogs here and I want to divide them into groups of 3, you can't always divide things so that it works exactly right. Sometimes there's going to be something left over. And when this happens in dividing whole numbers, we call that the remainder. It's what's left if a division doesn't work out exactly right. And the remainder is usually written like that. So if we have 10 divided by 3, the result is 3 because 9 divides evenly 3 times, but we see that there's 1 left over. That 1 left over is called the remainder. Another way of illustrating that or indicating the remainder is by putting how many are left over the number you divide by. So we could also say that 10 divided by 3, 3 with a remainder 1, is split into 3 parts. And later, in a few more chapters, when we do fractions, you will see that splitting 1 into 3 pieces gives you 1/3 each. So for example, you could think of it this way. There's the extra hot dog. I take a knife to it, and I split it into 3 pieces. Now everyone gets an equal share. Well, I guess you could fight over who gets the biggest piece. I remember I always did. But again, we have 3 1/3, 3 1/3, 3 1/3. That will equal to 10. Again, we're going to talk much more about this when we deal with fractions. I just wanted to show you how that relates to division if we have numbers that don't divide evenly. If we have remainders, what can you do with the remainders? Well, one thing you could do, of course, is say, all right, nobody gets this one, or we find someone who may want it. The other way is to take the hot dog or whatever and try to slice it up evenly into pieces that are smaller than 1. So those are the ways we can deal with division. Well, so far, everything we've divided has been relatively straightforward. 12 divided by 4 is 3, and so forth. How about something a little bit more complicated so that we can look at the process of dividing anything that might be thrown at you? And we'll use the idea here of successive subtraction. Well, this is the process that I'm going to get into. Is called long division. And you'll find out why it's called long division, because it's a long process. But it's something that we would like you to get used to as a way of refreshing your math skills. Later on, of course, we can always do these things with calculators, but initially, in these first few chapters, in these first few classes, we'd like you to do it longhand without a calculator. Of course, you can always use a calculator to check yourself to see if you've done it right. Let's look at the process of long division. So here we go. We're going to take 1015 and divide that by 7. And the best notation to do that is the standard division notation, where you have the 1015 under that L-shaped bracket with the number you're dividing by outside it. And so what we're going to do is successively subtract 7 times different powers of 10 until we wind up with nothing left. So let's see how that goes. First of all, we see that 1015 is bigger than 700. So the first thing I ask myself is how many 700s are there in 1015? Well, if there are two 700s, that would be 1400, too much. So I have to back off a little bit, and this is the kind of thinking you need to do. And so the biggest 700 that I can fit in 1015 is 1 700. So what I do then is write a 1 there and write in the 700. So right away I'm subtracting 1 700 from the 1015, and when I do the subtraction, I see I have 315 left. Now the next thing I can ask myself is how many 70s are there? Notice how I'm going down in powers of 10. I've taken care of all the 700s that fit. Now I'll ask how many 7 times 10s or 70s fit. So how many 70s are there in 315? I remember that 7 times 4 is 28, so I take a guess, 4, and that gives me 280. And so then I subtract the 280 from 315 and get 35. Now I'm down to asking how many 7s are there in 35. And I know that there are 5 7s in 35 because I've studied my multiplication table. 7 times 5 is 35. I take away the last bit, 35. 35 times 35 leaves me with 0. So the answer is, the quotient is 145. 1015 divided by 7 is 145. And I see that the remainder is 0. There's nothing left. So this was the process of taking away, taking away, taking away until I have nothing left. Let's look at another example. Let's look at the way this is more commonly done. We'll use the same numbers, but do it a little bit differently. You don't need to put in all the zeros. I'll show you the technique that we've all learned to use in school. So we ask, first of all, how many 7s are in 10? Really, we're dealing with the 700s because notice that 1 is in the hundreds position. We subtract the 7 from the 10. Remember, we could put all those hundreds in, but remember, as in multiplication, we've left a lot of the extra zeros out and just kept the places correct. So then I subtract 7 from 10 and get a 3, bring down the 1. So the next thing I'm dealing with is the 70s, but now in that 10s place I ask, how many 7s go into 31? And the answer is 4 7s. 4 times 7 is 28. I subtract 28 from 31 and bring down the 5. Now I have a 35. I'm dealing with the unit terms, the 7 terms. Ask how many 7s are in 35. 5, like before, subtract it, get 0. There is no remainder. This is the more common way of dealing with divisions. Now, just like we can check our subtractions by adding, we can check our divisions by multiplying. So now, in order to check by multiplying, I take the 145 I got as the quotient, multiply by the divisor, and I find that I get the dividend, the number I started with. So I'm fairly sure that my division was done correctly. And this is always something you can do. Whenever you do a long division, it's perfectly okay to check your answer by multiplying the way I did here. Let's change this problem ever so slightly in our next example. Instead of 1015, let's use 1017 and do the same division. So first thing I check is the 700s term and ask how many 7s go into 10. 1 7, subtract the 7. This is exactly what I did before. The 10 minus 7 is 3, bring down the 1. Now I ask how many 7s are in 31, or how many 70s are in 310 if you want to put all the zeros in. Works the same either way. There are 4, 28, subtract there. Now I have 37. How many 7s are in 37? I see that there are 5, so I subtract the 5 away there, but when I do, what happens? I see that as I subtract, 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 there's some left over when I'm done for everyone to argue about if we were talking about dividing cookies or lottery money. So what happens? That's the remainder, and that's written in as R2. So our answer for that is 145 remainder 2. Let's look how we would check that. There is our division example, and what we would do is check by multiplying, and then we leave out the remainder, and then we have to put that back in. So the first thing we do is multiply the 145 by 7, get 115, add the remainder, and we get 117. And so we see we've done this correctly because our result is the number we started dividing by, or the number we started dividing. Let's look at something a little bit more complex. Let's look at 1,917 divided by 12. So again, we need to first deal with how many 1200s are in 1917. And when I do that, I see that there's, if I have two 1200s, that's 2400 too much, so I have a 1 there. Okay, then again, I'm not going to bother with the zeros. I'll do it the way we normally do a long division. So subtract 12, bring down the 1. And so first thing I ask, how many 120s are there? Well, there are 5, and so I get 60 there. In other words, 5 times 12 is 60. Now I can subtract there and bring down the 7. The next thing I ask is how many 12s are there in 117? And you're going to have to experiment. You might need to try a couple of different factors in there until you get it right. I know sometimes you try 5, it's too little, 6 is too much, 7 is too much, and you need to fool around. But let's try a 9 there. And we get 12 times 9 is 108. Then we see that we're going to have a remainder of 9. So our answer to this division problem is 159 remainder 9. Now again, if we want to, we can check this by multiplication. 159 times 12 gives me 1908, but then we need to add in the remainder, and we get a final result of 1917, and we see that checks. The result of our check is equivalent to the dividend of that problem, so we're okay there. Let's take a look at some of the rules for division. They're not quite the same as they are for addition or multiplication. You can't be quite as loose with division. It matters where things are in the division equation or in the way the division is written out. Let's take a look at that. First of all, division isn't commutative. What that means is A divided by B is not equal to B divided by A. You can't swap it around. 8 divided by 4 is not the same as 4 divided by 8. 8 divided by 4 is 2. 4 divided by 8 is something we're going to talk about when we deal with fractions. Another thing is that division isn't associative. And what that means is you can't group things. Depending on how you group things, you'll get different answers. The quantity, A divided by B, then dividing that is not going to be the same as if I start with A, divide B by C, and then divide that. Let's see what, if we put some numbers in, let's see what's going to happen. So if I have 24 divided by 6, that gives me 4. Then I divide 4 by 2, I get 2. On the other hand, if I have 24 divided by 6 divided by 2, that'll give me 3. 24 divided by 3 gives me 8. So you see, depending how you group divisions, if you do successive divisions, you'll get different things depending on which two operations you choose to do first. Any number divided by 1 is just that number. And the way we would put it in the most general sense is A divided by 1 is just A. to play with a number. 23 divided by 1 is 23. Really what you're saying here is if you take all you have and make one group out of it, that's still all you have. So any number divided by 1 is just the number you started with. Now here's something that's quite interesting. Any number divided by 0 has no definition in our math system. So if you have something divided by a 0, you can't define it. And the way to think about it is, for example, if I have 24 and divide that by 12, by 2 I get 12. If I divide it by 3, I get 8. And so as the number you're dividing by gets smaller and smaller, the result, the quotient, gets bigger and bigger. And what ultimately happens is you get a number so large you can't talk about it that literally has no definition. So dividing by 0 is a no-no. You don't do it. If you see something divided by 0, it is mathematically undefined. And if any number divided by 0 is undefined, then 0 divided by 0 is definitely, you're not going to talk about it. We don't divide anything by 0. If you do, you just say, I can't do it. Now let's talk about divisibility. If you look at any quantity, can you tell right away what kinds of things are going to divide it evenly? So, for example, if the last digit is an even number, 2, 4, 6, 8, and so forth, or 0, then that number is divisible by 2. In other words, we know that if the number ends in 0, 2, 4, 6, 8, 10, 12, 14, 16, and so forth, if we divide it by 2, it's going to split up with nothing left over. Sometimes that will be useful to us mathematically to know that, and often we can have a quantity and see how long we can keep dividing it by 2's. So for example, I have say a bunch of cookies. I split those in 2, then I take each of those groups and split them in 2, and as long as I have even numbers, I can keep splitting them in 2 without having to chop any cookies in half. Divisibility, again, if the last number is 0 or 5, we know it's going to divide evenly by a 5. So for example, 45 divided by 5 is 9. 40 ending in a 0 divided by 5 is 8. Now, let's look at some of the ways we can use division with word problems. Here's a common one that often leads to some interesting, shall we say, discussions. We have 22 co-workers who win a pool of $32,032 in a lottery. We'd like to know what each person's split is. So just as we've done before, let's identify what we're given and what we're asked. We're given we have 22 co-workers in the pool of $32,032, and we want to know how much each person's split is. So we've summarized the information, and the question is, what does each one get? If we analyze it, we want to divide the total into 22 equal parts. So here we go. We're going to do a long division. So when we work on this, how many times does 22 go into 32? 1 time. So we subtract 22 and get 100. Then we ask how many times does 22 go into 100? We get 4, subtract 88. 22 times 4 is 88. So we have 123. We ask how many times does 22 go into 123? I see that's 5 times. That 5 times 22 is 110. Then that gives me 132 left. 6 goes into 132, and it looks like it's going to leave me with 0. So the answer here is that everyone in the pool gets $1,456. That's not bad. Let's look at another problem that is fairly common and one that I've run into at least. The inside walls of a house are 11,056 square feet. 1 can of paint covers 175 square feet. How many cans of paint do I need? So there's the information I'm given, and there's what I need to know. So here is the synopsis of what I'm given. Here's what I need to know. And what I need to do is divide the total area by how much of the area is covered by each can. So let's do that long division. So when I work that out, how many times does 175 go into 1105? And I find that goes 1050. Do the subtraction. How many times does 175 go into 556? 3 times. And I see that there's some left over. So what that tells me is that I'm going to need more than 63 cans of paint, or I'm going to have some little piece left over. And so I need to buy 64 cans. Now you can also use division doing equations. So for example, suppose we have 5 times x equals 35. So just like we did before, we'll put each of those quantities on either side of the balance and think of the pivot as an equal sign. And remember what we need to do, we have to do the same thing to both sides of the equation. We need to divide both sides of the equation by 5. And you see here, I'm using the symbol for division where I put it over it. And when I do that, 5 times x divided by 5 gives me x equals 7. So if I have the variable multiplied by something, I see that I can divide both sides to get x by itself. So here's another example. Sam is thinking of buying a trailer with a given area and a given length. And we want to know what the width is. So we do the same thing. The length is 56, the area is 1094. We want to find the width. So the area is the length times the width. So we analyze it this way, and we get 1094 is 56W. So we use that technique where we divide both sides by 56, do the math, and find out that the width is 34 feet. And notice that in my answer, I put the 34. So let's review. Here are the things we've seen how to do in this unit. We've seen how to divide whole numbers, and remember that's the process of splitting things out into equal numbers within a certain number of groups. We've seen how to solve word problems involving division, and it usually involves a split. How many different ways can I sort things into? So for example, if I have a certain lottery sum and want to divide it into how many people I have. If I have a certain quantity of food and want to make sure that everyone gets the same amount of food. All of that is division. So anytime you see a process of splitting things up evenly in a word problem, you're talking about division.